Uh, okay. So shall we start then?
Yep, let's go.
Okay. So for first bit about me, I'm Adeesha Jayasooriya, SSC from Aventrio, and also I'm certified AWS Associate Solution Architecture uh, for about 3 years. Uh, so So we are doing some tech sessions, and this is the third one. It's about serverless computing. So let's start. So today we want to talk about what is serverless, serverless architecture, and comparing serverless versus multi-tier architectures, and serverless benefits and drawbacks, and some of serverless technologies. So, what is serverless? So, before move on to the serverless let's hear about some about multi-tier architecture. So, multi-tier architecture is actually traditional approach. We all know about it. First presentation layer, then application layer, then data layer. So the presentation laying on client side, application lays on business logic, and data lay we store data. So that's actually we do uh, now. And so from here for application layer, we need servers and firewalls, and so the communication between application and presentation layer, we need firewalls and all of that. For the data, we need database and database servers. So many resources with this architecture, and there's a requirement with this architecture and maintaining all those resources. So when we come to serverless, let's especially see how this multi architecture difference from serverless architecture. So before we talking about serverless architecture, uh, we backend as a service. Backend as a service we call BaaS. Those are uh, BaaS means server-side logic and state hosted by a cloud provider utilized by client and application. That means simply cloud provider providing APIs and clients are using their APIs. So kind of like serverless, right? So uh, mostly mobile application use this method. Uh, Example of authentication from Google. So Google provide authentication APIs and most mobile applications, and now web applications are also using that API. So is this serverless backend as service? Actually, no. The end of there is bunch of APIs because the full application are not rely on backend as a service. So it's not serverless. So, but backend as a service is a part of serverless. So then comes a function as a service. Function as a service means developer can provide their own code executed by event triggered containers that dynamically allocated and ephemeral in nature. So what does mean? So in here we see event triggered containers. The event triggered containers means the event triggered means the containers wait for request to start. So after the request comes, only the containers start, and see dynamically allocated. Then that means no certain number of instances on the that. So in the function as service, there are no certain number of instances. There may be uh, can be thousand or one or any number of. So ephemeral means lasting only for very short time. As another example, as EC2 server, it can uh, it's lasting anytime that we want, but it's not in function as service. It's a limitation on the time it working. So this is actually serverless. So when we talk about serverless architecture is uh, runtime architecture whereby infrastructure is entirely managed by a cloud service provider and resources are dynamically allocated on demand for giving unit of business logic. So I think there's a lot of jargons there, though, so you might not understand it. So here, what's the simple say? Small pieces of codes that execute on cloud provider without developer have to worry about the infrastructure. So it's a small pieces of code, some number of codes pieces, and it's running without worry about the architecture. So that means no VPC, no firewalls, no instances, no network rules, so etc. So many subnets and nothing is there. So, but one thing is in serverless architecture, paying for service key. We have to pay for every service key. That means service architecture. Let's me show what is service architecture look like. Uh, Here I am going. If you have any questions, you can ask me. Uh, uh, so serverless architecture look like this, and as you can see, it's a application is on top of them. Below that, fast and bars. Fast means function as a service. Bars means backend as a service. So backend as a service is part of a service. Uh, the APIs are part of a server. So this a cloud provider is their cloud provider only providing the infrastructure. So let's talk about serverless versus multi-tier. So in here, skill in terms of its skill set, serverless in here need development only. Developer need to know about development things only. But in multi-tier, it requires operations means you have to think about all the network things, uh, VPCs and instances, and how many memory we have to look up to storage reasons, all and handling those operations, all the things uh, a developer or network engineer need to know about all those things in the multi-tier architecture. And with the cost, we can start up at low cost in serverless. But when it comes to uh, number of people are increasing. I mean, the cost in the serverless cost is based on number of user requests. So in the user request number of requests increases, cost is gonna go much higher than the multi-tier type of normal instance. So, and other than that, in the multi-tier, so we have to acquire hardware upfront. Even in the cloud, we have to buy EC2 instances before going on to working. So that's in the multi-tier architecture. But if users increases, that payment is not going to increase. That's what I mean, that's what the multi-tier architecture is good for. So we're going to talk about it more later, and we think about use cases. For the serverless is more suitable for adding core seasonal traffic. Means sudden we expecting sudden unexpected traffic, or some season has huge traffics that can be easily handled by serverless than multi-tier. So it's actually best for that kind of services. Also, uh, startups actually. Normally, when we start, that's really good. But for multi-tier architecture, actually, for workload is not suited for the cloud. That means continuous workload means if we know the uh, workload uh, amount is continuous, so it's not gonna much gonna change. So we know the bandwidth of the internet, we know the what we want storage, so that so then we no need to go for a serverless, because we can handle that with multi-tier architecture. And also, if they have sensitive data, that is actually not good with serverless, because we actually don't know how our data process and where our sensitive data is. And actually we can't control them, we can't control that data. So then next, we're going to talk about some serverless benefits and drawbacks. So talking about benefits, the serverless is have no infrastructure management. So that's the main reason, main benefit of the serverless. So we don't have to maintain infrastructure, and that uh, is really good one. And in then we have built-in scaling. That means we don't have to think about scaling. So it's built-in scaling. Anyway, gonna scale up to any time, scale up or scale down anything. So actually we don't have to worry about scaling in terms of cost also. So that's it's a really good one. And also reduce operational cost. That means, so actually for in multi-tier architecture we have to work on VPC and all the connecting networks and firewalls that actually requires a person. So person maybe a team or to handle that. So that cost is gonna go away with the serverless. And simplified deployment. So yeah, so no need to no hard way of deployment, is simply we can deploy with the serverless architectures. And the drawbacks of serverless architectures. Uh, Main one is to become vendor locked. That means, think about if you start with AWS, you start with AWS servers, but then you can't actually move on to the Google Cloud or something, or Azure or something, because the serverless cloud providers are different different systems with each other. So you're going to be vendor locked for with the uh, uh, whichever you started cloud provider. The change is gonna more costly, and the Then one is the multi-tenancy concerns. Multi-tenancy concerns means actually our data, we don't know how our data is processing. Normally AWS is using all the accounts with uh, their servers is going to be multi-tenancy. Multi-tenancy means our codes are running with others codes, right? When our codes are not running in their servers, our uh, another person's code is running. So for one server, about many accounts is working on there. So we don't know how our service is. This is important because if we have sensitive data and we need dedicated instances without multi-tenancy, that is gonna concerns and no ability for infrastructure optimizations. So that means, so yeah, we don't have any access to infrastructure actually, so we can't access all that. So if we handle that, that's it. So monitoring can be complicated. Yes, monitoring infrastructure will be much complicated in because in the serverless we have to uh, check the logs, right? So in the monitoring and something else, so we have to work on the logs and in the serverless we can't see the instances and also we don't know what's going on and all. So we have to check always the logs to see what's going on. Mostly cloud providers providing logs like AWS providing CloudWatch. And also it's a drawback because uh, we have to pay also the logs. That's so CloudWatch is also taking cost for their logs. No, that's like that. So yeah, here is all about benefits and drawbacks. Mm, so any questions up to par before moving to serverless technologies?
Adeesha, so
Oh,
when we are designing, like let's say we have got a new system to build, and then we are deciding which to select serverless. I mean serverless bus, FSO, multi-tier. How do we decide? Like what's the is there like a rule of thumb in deciding based on the requirement?
I think there was a slide before this. Adeesha, can you go to the previous slide?
previous one.
I think this was some.
Yeah. So let's say we have a requirement and we have a set of like use cases. Like, is there like a guide, like this specific, like this kind of use cases are more suitable for serverless, and this kind of like for multi and in serverless, these are more backend accessories and these are more function accessories.
Yeah, like backend as service means we don't have access to APIs or business logic. Backend as service used for mostly on mobile applications, uh, or we can use for uh, web apps too, but it's more suitable for mobile applications because we just have to access only. So when there's a our own business logic, we can't handle that.
Okay,
We
like
have
Firebase.
backend as is like this. It's just APIs.
So it's
So
like a feature, right? Someone implemented that. We don't have
yeah, someone
control.
like implemented that. So
Ah,
we are using that.
right.
So it's not like Firebase.
It's not like Firebase. Yes.
So it's actually part of a serverless, but not a
Not
serverless.
so to be clear, serverless consists of everything, right? Bash and
Fast.
fast.
Yeah. Yeah.
It's a combination of that.
Combination.
Okay, so the
So
yeah,
other things of the is that clear then?
yeah, that part is clear now. So the question is now
Like,
how to
yeah, can you like
So
give some?
traditional the,
Yeah.
okay.
No, I'm thinking like let's say now there like it is maybe some examples like these kind of situations we should go with serverless because oh yeah these kind of things are going with serverless, so maybe these kind of things are good to go with serverless at the beginning, but if when scaling it's better to like let's say we know that this particular service is going to be used by 100,000 users per month in the next 3 to 6 months. So if we know that kind of information, how do we select whether this is going to be serverless or going to be multi-tier?
Uh, that is like so. So when you actually serverless is most suitable for when you start that because you can speed up the process, right? I mean, you can you don't have to worry about infrastructure and all. You can serve your application rapidly. That's one of the main things. So vignette is and low startup cost. That's one of the biggest things. So cost is low and we can fastly move. So start actually serverless is good, but actually the problem was when the more users coming up and more requests coming up, especially rather than users actually the number of requests is the serverless is counting. So that that cost us a really lot than normal multi-tier approach. So uh,
Okay, okay. So
okay.
if we start with serverless, let's say AWS specific, let's say we do a Lambda serverless backend, and we want to migrate to a multi-tier later. If we are still inside AWS, is there like specific services we can use without rewriting a lot of code?
Right now, I don't think there is kind of a things.
Hmm.
Uh, uh, there are similar service like EC2 like if I go for the serverless technology side, I'm thinking about this later.
Ah, okay.
Oh, no, it's okay. I mean, the Fargate one, the here compute one is similar to EC2. But so we can up any Docker container to that, and
Ah,
okay. So that can easily move. But I don't think Lambda like fast service we can do easily.
yeah.
Is there any method to do that?
Okay, okay, okay. Yeah.
okay. So I have actually a follow-up question. So Lambda is obviously easier to develop and deploy, right? So let's say we started with Lambda. What kind of a situation? I mean, what kind of reasons that would make us migrate out of Lambda?
Uh, Actually, the I think only the cost is the most reason. I mean,
Okay.
you have coming up the I mean, lot of requests to you.
Okay.
Lambda is more costlier than other.
Okay. So
So if yeah,
as it scales up, it becomes
yeah, I think
cost.
if we have like continuous request like an 24/7 මේව තියෙනවා
Right.
නම් it makes more sense to
Okay. Lot of
yeah,
if it takes a lot of processing time,
yeah,
might
may
make
make
sense.
sense to get a this thing.
Okay. So otherwise, it is beneficial for us to
Yeah.
use keep using Lambda.
Yeah. Okay, okay, yeah.
Yeah. Good.
Uh, okay. Okay. So let's move on with the AWS technologies. So the main actually I have to I forgot to tell about time. serverless technologies, but I'm mostly talking about AWS technologies. They are the Google Cloud and other Azure, and also have serverless technologies. So I'm here talking about AWS technologies. So started so AWS technologies has three types. So compute type is Lambda. Lambda is their fast solution, AWS. So, and as I explained, AWS Fargate is for Docker containers. Actually, you can uh, up any container to that. You have a container. If you put that, and it works in uh, it working. So then move on to the application integration. There is SQS. SQS means simple queue service that similar to what we using in the RabbitMQ or other queues we are using. So then SNS. SNS is simple notification service. Simple notification service means we can send emails. It's for notifications, so we can send emails and also emails and SMSs. Also to actually trigger events also we can. So Lambda trigger events also we can use SNS. Then there's a event bridge. Event bridge means for actually event-driven applications. Uh, then step function. Step function is important with the Lambda because Lambda is short-lived function. So we have to run a number of functions in together. That where comes the step function is coming. So we can run multiple lambdas in together. So as example, you have to send notification on to SNS. So via SNS. So from lambda. So from one lambda you do the task, and next you have to choose which function you gonna choose for notification, send the notification, either email lambda function or either SMS lambda function. So that can build by the step functions, so like that. So and there's a API gateway. You can simply build a API gateway with API gateway for any app. So it means for Lambda, for S3 or whatever. So it's for that. Actually, API gateway is a kind of like a BaaS service. So it's giving APIs. That's right. And there's a sync serverless GraphQL. It's actually for other serverless for Lambda. Sorry. Databases like DynamoDB, Aurora, and kind of like serverless for databases, we can build serverless GraphQL functions with the fsync. And there is data stores. S3 is object store, so I will talk about later. And EFS is their serverless file store, similar like EBS, but it is serverless. And DynamoDB is key value store, serverless key value store. And RDS proxy is for allows application to pool and share connection, establish the database. So for the and improving database efficiency and application scalability. And Aurora serverless is similar to Aurora is AWS's RDS solution. RD means relational database solution. So it either can compatible with MySQL or PostgreSQL. So if your relational database to be serverless either MySQL database or Postgres database, you can move on to the Aurora serverless. And Redshift is data lake solution of AWS, and Neptune is a graph database solution for serverless in AWS. So here we let's I'm uh, uh, choosing few of solutions, few of serverless services here. So let's talk about Lambda. Lambda is AWS fast service. Uh, you can upload code to it by zip or container image, and there's so as I can say, for the function as a service, we have to trigger the function. So the in the Lambda, we can trigger events in many ways. For a Lambda, we also have a limitation of short-lived function. So Lambda is giving 15 minutes limitation. Actually, it's a good limitation. 15 minutes actually can do a lot. And okay, Manoj.
This about a step function can
in the previous slide.
Yeah. Is it can we like if we have a workflow, like I think we had a couple of use cases when we built previous projects as well, where we wanted to send a task to multiple functions, right?
Multiple means there are like multiple AWS services as well, like
Yeah.
serverless, multiple AWS serverless services like Lambda and S3 and a couple of
like in interview, right?
And DynamoDB. Can we orchestrate all of that using step functions?
That is, I don't think right now they do that. I think step function is for Lambda.
Just for Lambda.
Lambda.
So we can get output of one Lambda, and through step function we can redirect it to another Lambda, something like that.
Yeah, like that.
So orchestration is just for the Lambda, right?
Yeah,
Got it.
Okay, and it's actually really low cost. They are using $0.2 for 1 million requests. So for the startup, coming 1 million request is rare. So that's is really good solution for them. But also there's additional cost for here with the time running on the Lambda. So Lambda is time running time also the cost, and also you have to pay for the cloud logs. That also there. Here, let's move on to the API gateway. API gateway is for create, maintain, and secure APIs. So it's a API. API for you can put an endpoint to the API in here. So so you have to pay only for the API calls for you receive and amount of data transfer out. So that's $1 for 1 million requests, and there are few methods of API gateways: HTTP API gateway, REST, and it's also you can use as a WebSocket is available. Then we'll move on to the DynamoDB. DynamoDB is AWS managed NoSQL database. So it's just like a key value store. Uh, it's guaranteed 99.999 availability, right? And it gives us a encryption at rest solution, and also on demand capacity. You have any number of capacity in the storage and the bandwidth also. And also works for indexing too. So the fast search is we can create indexes for too. Um, Another services I'm talking about S3. S3 is a scalable object store. Uh, we can put any objects, any files you have for the S3. So it's actually have durability of 99 point, actually 11 nines. We talking about 11 nines durability. We say like that. So it has 11 nines durability. So it's a pretty good service, and you don't have to think about the S3's storage amount. So you can control access to the object either by S3 buckets or the object or the either objects wise also. And there are a number of storage classes based on the uh, uh, availability. Actually, it's not availability of data; it's based on availability. I I will explain actually the hands-on in few moments like this. So, example, there's a standard storage class. The availability 90.999%. It costs only for 1 GB for $0.023. Uh, so I think for the technologies I'm talking about is this, and I'm gonna move on to AWS console to send you a hands-on experience on what looks like the functions and all. So yeah, I think you can all see the AWS uh, S3 typing. So I'm just started some buckets creating. So so I'm trying to this should be working actually because AWS name is global. So it must be globally unique. So you have to this unique database. You can't. They are not going to like the taxation is not gonna work. Already there is a bucket like someone is built. Something will be someone like this. And okay. So here we have ACLs. For case I actually do for object writer here. and I'm giving all the access to the public. Let's create a bucket. Okay. Oh, this is not the bucket I created. Okay. Yeah. This is the bucket I created. So I'm gonna try to upload the object. This is some index HTML I took from inside. In here, you can this access control list. I'm giving public access to this. In the properties, that what I mentioned about the storage classes. So in what tier you want to work with, right? This is actually based on availability. So it's something like so I'm gonna put the standard. Uh, I think it's opening from another tab. I will share that tab. So here you can see you have object URL. If I copy the object, like this, right? And simply you can build a static website like this in a fast way. So that's what AWS is really, sorry, Serverless is really good with the fast applications. So at the same time, I will go back. And let's say we are going to Lambda. Actually, there's a few functions actually I built. This is the look Lambda function. So as you can see, there's an event trigger, right? Event trigger to the function. Here we can also add another trigger. You can see there's a lot of ways to trigger the Lambda. So this code is actually doing, as you can see, it's connect to the DynamoDB table and actually scan the table and return the items. So let's see it's working. Actually, it's connect to the API gateway. I go here. That's the API gateway endpoint, right? So I'm gonna put that API gateway endpoint as here so to do and work something like return. So I will go to the where I return from. So it's actually getting the from DynamoDB the data. So this is the DynamoDB database we have. So let's go the items. Yeah, here. In the item, it's only work is in there. Actually, our time is running out, I think, right? Hmm. So there's another lambda function actually I created for post request. Uh, as you can see, oh yeah, another request for the post. So here the put item and this item is the to do. Let's move on to the I will share my entire screen. Oh, uh, okay. Okay, here is my uh, to do post request. So I will put some okay session. It comes as a done. So it went through and let's see it on DynamoDB. I think you can see my screen.
Yep.
Okay, thanks. So likewise, you can see the session object is also came up. And if we check with the get method, should on like session and work is also okay. Is there anything I can show? Okay. Yeah, we can show API gateway. I didn't show you the API gateway. Yes, I created HTTP API gateway and the invoke URL that's the same as one. And here we go to the routes. You can see get and post are there. So it's actually configured to the configured to the AWS Lambda functions. Right. Yeah. Here is what I actually built. Actually, I wasn't able to work on the front end side. So this is the web application, and from the web application, from the S3 bucket, web application is upping and is connecting to the API gateway, and then you can post from to DynamoDB and get this get from the get function. You can get the data from here, and yeah, that's all. Any Q questions?
Anyone has follow-up questions?
Yeah. About anything you want to know about AWS or anything?
Yeah. You can also post in Slack later. We'll upload the session to YouTube. And the slides are you got
So far we haven't.
Ah,
I think we can upload it
yeah,
somewhere.
we'll have the slides posted somewhere
Yeah,
as well.
we'll have a shared drive
Drive,
where
yeah.
we have all the slides,
Yeah.
all the sites that we have done so far.
Yeah.
Yeah.
Okay.
Yeah, guys. Guys, anything else? No? Okay. Cool.
Anything?
Yeah, I think.
Yeah. So we'll wrap it up. Thanks, Adeesha. I think that was really useful. We'll also put it on YouTube so that we can share it around. If there's any questions, we'll discuss it on Slack.
Yeah.
Huh?
Yeah.
Cool.